Okay, let's take an example on computing the mod for very large numbers with powers. So we said the first step is to take the power and break it down into powers of 2. So to do this, I have to convert this decimal 20 into the binary representation, which is a bunch of zeros and ones. And to do this, I use this to bin, decimal to binary, and I put the 20. This gives me this representation in binary, and then I take it and make it into decimal to see the numbers which are equivalent to it broken down into bases of 2. So I will take 20. This is in decimal, it's equal to 10100. So next, I've got to label them. This is digit number 0, 1, 2, 3, and 4. So this is all base 2. This is going to be 2 to the 4. Skip. This is going to be 2 to the 2. Skip, skip. We've got only 2. And I know that 2 to the power 4 is equivalent to 16. 2 to the power of 2 is equivalent to 4. 16 plus 4, yes, it is equal to 20. So I am going to replace the 20 with 16 plus 4, which are both a base, a representation of the base of 2. So now what do we have exactly? What to the power of 20? I have 538 to the power of 20. 538 to the power of 20. So I'm going to just rewrite it as 538 to the power of, and instead of 20, I'll just use 16 plus 4, which is the same. Then using the rules of indices, I'm just going to take the same base raised to each of these powers. So this is equivalent to 538 to the power of 16 times, using the rules of indices, 538 to the power of 4. Okay? And this is, of course, both of them are mod 1520. So now I need to have the power all the way to the 16. And you can see here, you're lucky because they put all of the steps for you and they are reaching all the way up to the power of 16. So let's evaluate what they want. Of course, we're going to start with the power of 1. So 538 to the power of 1 mod this. This is a smaller number. So smaller number mod bigger number, it is the smaller number. Then I start squaring. I got it squared. I can do this in octave. So I'm just going to go ahead and say mod of 538 squared. Okay, squared mod 1520. So 1520. This gives us 644. So I'll take it and put it here. Every time we're going to square till we get to the 16. Okay, so now I took this and I squared it. And we said whenever we start doing this, the way to get the answer is just to take the previous number, square it mod. So that's what I am going to do. Now we have mod. I'll take the previous number, which is 644, square it mod. And the answer is this. To get to the next answer, I do the same thing. So you can use the upper arrow and I will replace this with the previous number. So previous number is this, squared. I get 16. To get to the next number, I do the same thing, upper arrow, and then I'm going to replace this with the previous number, which is 16. So just put 16 here and you get the answer to 56. We're done with the squaring. Now to get to the final answer, what do I have to do? Well, I have it right here, as you can see, 538 to the power of 20. I replaced it with 538 to the power 16 times 538 to the power 4. And both of them, they are mod 1520. So I get this one mod, and then at the end, don't forget to add the mod. So 538 to the 16 mod, this is the one. Okay, so I take this answer. So let's just do it right away. I'll take this answer. And then I need to multiply it by the answer of 538 to the power 4 mod. This is the one for the to the power of 4, so this is the answer. Okay, and both of them, of course, are mod 1520. So the final answer is 460. 460. Now let's get to the last part, which is the modular inverse. The modular inverse. So if we want to find the modular inverse of a number, mod n, this is the modular inverse. So if I want to find I, this is the same as if I say a times this value is equal to 1 mod n, is congruent to 1 mod n. It means if I take a and multiply it by this value and divide them by n, I get the same answer as if I take the 1 and divide it by n. It's the same remainder, okay? So meaning that a times I mod n should be equal to 1. The remainder of dividing a times I by n is equal to 1. So I'm thinking of this number that I can multiply a by, and then at the end, if I divide them by n, I get a remainder of 1. And this is going to be the inverse. So this is going to work. We're going to be having an inverse only if a and n have the GCD of 1. They've got the greatest common divisor between them as 1. They are co-prime. And I can find this number that I can multiply a by to get a mod of 1 when I divide by n, but using the extended Euclidean algorithm. So we've done this in Moodle before. So if you just go back to the exercises in Moodle, for example, here they've told you that 66 and 23, they've got a greatest common divisor of 1. So this number and this number, they have a GCD of 1. It means I can find the inverse. So here they're asking you to find the inverse of 23 mod 66. And they just take you through the Euclidean algorithm. Then you can go to the next step, which is the extended Euclidean algorithm to get the Bezoos coefficients, and then take the greatest common divisor, which is the 1, and express it as a linear combination of both these numbers with the Bezoos coefficients placed as well. And now from this, what we want to find out, we want to find out the inverse. Okay, so how do we get from this step and find the inverse I? Now they want the inverse of 23 mod 66. So if I go back to the definition, I'm thinking of a number that if I multiply 23 by and I find mod 66, I should get a remainder of 1. Now, how can I get to that number? Well, I can get to it from this linear combination equation. We're trying to find mod 66 and we get 1. So I'm just going to take the entire linear combination equation. And of course, the GCD, this right-hand side is equal to 1. And I'm going to find the mod of 66 for the entire thing. So it's the same thing here. This is the linear combination equation, and I'm trying to find mod 66 for the entire part. So I'm going to take it one term at a time. I'm going to start with 66x mod 66. So if I take 66 times any number, and then I divide it by 66, what is the mod? What is the remainder of dividing 66x by 66? Well, if I divide 66x by 66, I would get a number, which is x, and I wouldn't get any remainder. So the remainder is going to be 6. Any multiples of 66 multiplied by 60, any multiples of 66, okay, 66 times whatever, divided by 66 is going to give you a quotient, which is a whole number, which is the x, and there is no remainder. So the remainder is going to be 0. So if I find the mod 66, this entire thing is going to be 0. So this leaves us with this, 23 times y, mod 66. Okay, just left it as it is. And then the other side, we have mod 1 mod 66. Small number mod 66 is equal to 1. This leaves us with this equation. Now, going back to the definition and then just comparing both, I'm thinking of a number that if I multiply it by the 23 and I find mod 66, the answer is 1. This is going to be the inverse. So in this case, my inverse is going to be the number which I multiply by 23, which is the y. Okay, so here, whenever they ask you find the inverse of a certain number, how can you find it? Go to the equation and see this number. It's multiplied by what? This is going to be its inverse. Let's take another example. So this is from Moodle as well. You go through the Euclidean algorithm and the extended Euclidean algorithm, and you got the Bezos coefficients, and you've got the linear combination equation. And they're asking you find the inverse of 127. So what do? Simply go to the 127 part and see what number is multiplied by it. This is going to be the inverse.